Hello YouTube, RJ. Hey, I just wanted to go over a few things with the Lynx Easy Shortwave receiver. Don't get too concerned about the wood. That's just me playing around with making templates for layout. This is the plates that go on the little case that I'm using. But I did do a little layout and everything does fit, but that's not what I want to talk about today. Today I want to talk about the software, some issues I was having, some features I wanted, what I changed to try to improve things. And for those that are interested at the end, I'll actually go in the code and show you what I changed to accomplish this stuff. So anyway, we got the layout here. Your antenna tuner fits in, your encoder for tuning, your step up and down buttons, and your audio amp volume. This hole didn't cut out proper, but the power switch would come through there. So the problem I want to show you is I've had noticed this, and it really started to aggravate me. So let me show you what the original code does tuning. And I think maybe they had higher end encoders on their projects, and so this wasn't happening. But those encoders cost, half the cost of the radio to build. So I'm not using high-end encoder to keep the cost down, but there's no reason these encoders can't work just fine. I found that it really was a code issue. It was code that everything had to work perfect not to get you in trouble. So let me show you what it's doing. And then I'll show you the things I changed because of preference, but let me show you the thing I changed because it was a problem. When you tune, right now I'm on 1 kilohertz step. So you would assume as I turn this knob, we will move 1 kilohertz at a time. The only step you will see is 1 kilohertz. But that's not how their code worked. If you look closely, you'll notice that your hundreds and your tens are changing. You're going in quarters. And normally that's fine because what happens is you get multiple pulses between your detents. And so it goes 1 kilohertz currently per detent. So what they're really saying is they're saying per detent's 1 kilohertz, but we're not tuning by a kilohertz. We're tuning by some amount in between. And it had to do with how their code worked. And this is fine if everything is perfect, but I'll try to get it to mess up now. And it does it quite often. You're not going to spend much time tuning around. It doesn't do this to you. What it's going to do is it's going to miss a pulse or something at some point, and it's going to end up with me not on a fixed kilohertz, but on like a kilohertz 0.25 or 50 or 75. And the problem then is when you turn the knob, it goes kilohertz and you go 1.25, 2.25. And to fix it, you got to stop, go back, change your steps, fix it, go back to your kilohertz and start tuning, and it's going to do it again in a little bit. And it's very aggravating. So let me see if I can duplicate it now. You can see it stepping in between, and it will sooner or later, if I play with it, and it may take a little bit, especially with you guys watching. Okay, there we are. No. I can make it stuff in between the, okay, here we are. I'm in a detent. Notice I'm in a detent. I'm showing you that I'm in a detent, and I'm at 3910.25. I didn't want to be in between kilohertz. Maybe I'm in the ham band, and I know that typically they're on kilohertz steps, especially your sideband especially. I didn't want it to go in the middle. I didn't put it on 10 or 100 or 10 hertz or 100 hertz. So that's not good. That's not giving the end user what he asked for. And the problem now is, let's say I want to go to 3911. Well, I can. I go to 3911.25. And so now I've got this going on. So the only way to fix it is to go to a step. I can get in the middle, play a little bit, and I get it there, but it won't stay there because it goes to the detent. So what I can do now is, well, I can go down to 100 hertz, and I can do this right here. Okay. Now I can go back to my kilohertz, and I'm back in business. But that's ridiculous. That's just not the way it should work. So that needed to be fixed. The other thing I didn't like is we're only allowed to go down to 10 hertz. That's the smallest increments I can make. I can't go a hertz. And it doesn't even display the position for hertz, which kind of bugs me because it doesn't look right. That should be 3,910,000, not 10,000. So that bugs me, and I want to do something about that. and I wanted to be able to tune 1 hertz. I think if you're going to give people the ability to tune, there's not a digit on there I shouldn't be able to tune. You may get to an AM station that's not, you're perfectly not calibrated, and you might want to move 2 hertz to get perfectly on the station. So I want to get the ability to tune by hertz. I want to have that hertz displayed. I want it to step only the steps I tell it to, no in-betweens. And then one other thing is, because of broadcast, when you get in the broadcast bands, 4 and AM station stuff, they're all spaced 5 kilohertz. And as you tune with this radio, because it doesn't have a detector circuit in it, so that it gives it the ability to receive all the different things, sideband, CW, and AM, you've got the issue of the heterodyne AM as you tune closer and closer until you get to the frequency and you null out that you beat frequency and null out that carrier. So it would be quicker to tune the broadcast bands if we go station to station to station instead of 5 clicks to the next station, 5 clicks to the next station. We also wouldn't have to listen to the heterodyne going until we got there, okay? Because we would go dead centered on the frequency to dead center on the next channel. So I'd like to add 5 kilohertz. So those are changes I want to make. So let me now pause a moment, reload my new code in this. Let me show you the features and how they work. And then what I'll do is, for those that, as I said, those that want to know, I'll jump on the computer, we'll go through the code, and I'll show you how they were handling it, how I've changed, and you can see the minor little changes. I spent a while working on it, but it's not because it was hard code to do. It was more because I had to figure out what they were doing and where the code was that was doing this. And so, going behind people with code is harder than writing your own code by far. So let me get this reprogrammed. I'll be right back. Okay, I'm back. I've reflashed this. Let me click it on here. And now a couple things you notice right off the bat is you have your full 3 digits with your hertz position. Notice that if I go down to 10 and hit again, I now go to 1 hertz. I can tune by 1 hertz. I'm not limited to 10 hertz steps. Notice that also, if I go to 1 kilohertz and go one more, the next step's 5 instead of 100, 10. So I can go 1 kilohertz, 5 kilohertz, 10 kilohertz, 100 kilohertz, and then 1 megahertz. And so we can, so now let's go down to our kilohertz, right? Like we were previous, but now we're in my new code. And let me tune, and notice that as I tune, you will not see any in between steps. There's no such thing, because the end user, me, has decided I want to move 1 kilohertz at a time. I should not move anything but 1 kilohertz, in my opinion. That's the way the product should work. So now it only moves 1 kilohertz. There's no way to get in between. That is gone. That doesn't happen. And it works at every single digit can be tuned. If we go all the way down to 1, I can tune the 1 digit. I can tune the 10 digit. I can tune the 100 digit, the 1,000, the 10,000, or 5,000, I'm sorry, at a step, 10,000 digit, 100,000, and megahertz. So every digit is at your command. You have control over it. It doesn't jump in between and cause you to have to stop, mess with it. The tuning works very smoothly. It works like I expect it to. So I hope those changes are good. I hope that, that's things you will enjoy having. I think that's going to be helpful. The 5 kilohertz when you're in the broadcast stuff is going to be really nice. Go to your 5 kilohertz, and now we can go 10 to 15 to 20, 25, 30. We can step station to station to station. Maybe there's no station on the next one, but the next one there is. You won't have to tune through the heterodyne. You'll just jump straight to it, to your broadcast. So, okay, with that, let me jump off, get on the computer, and I'll show you what I did in the code. So be with you in just a minute. Okay, we're over on the computer, and I am in the original code. And what I want to do is show you just a couple of things to bring you up to speed. Let's jump up here. We'll come back to that. Let's come down to here. And right here is the main loop. And the main loop goes through and it looks for whether you've pushed buttons. If you've pushed the button to increase your step or decrease your step gets processed here by incrementing or decrementing the CNT variable. And that variable just gets upkept here, and there's a little bit of checks here that if you're decreasing it, if you try to go below 0, it just sets it back to 0 so that you can't go too low. You've got the same check here on high. There's 5 different steps in the original code. So if you try to go above 5, it will put you back to 5. So that's when you try to push plus and you're on 1 megahertz, it won't go up anymore. This is what creates that. After it comes through that, it runs through this series of if-else statements. And what it does is it sets up what the steps will be. For example, if you're at count 0, you're on the 10 hertz step. And that frequency step is 2.5. And so why 2.5? Well, because they're getting 4 pulses between the detents. So you need 4 times 2.5 to get to 10. Just as for 100, you need 4 25s and 4 250s to get to 1,000. They're counting each pulse and incrementing you a quarter for each one. And after 4, you end up at the step you chose. And that's what we were seeing as I was turning. As I'm between the detents, you can see it going quarters up. This is where our problem comes in. Imagine that you're turning, and instead of getting 4 pulses between detents, you ended up with 3. You wouldn't end up at a full, say a kilohertz step. You wouldn't get 1 kilohertz step. You'd end up with 750 hertz change, and that's what we see. And once you're there, then you turn to the next detent, you got all 4 pulses, so you went a complete kilohertz, and you're continuously then on that 0.25 or 0.50 or 0.75. And so this is what was causing us issues here, is how they handle this. Okay, if you come on down here, the next thing that involves is that CNT variable also updates the screen to show you what step you're on. If you're on CNT 0, it's going to have on the screen steps 10 hertz. On the other hand, if you're on 5, you've got steps 1 megahertz. So you can see you don't have a 1 hertz here, you don't have a 10 hertz here. This was me playing around before I made a copy and recoded the whole thing. This was me just playing around a little bit here. I remarked that out. To add these additional, I had to add additional here, add additional here. Now, let's get down to where it's really was an issue. This is another loop. While this loop is going on, monitoring for you to make changes and such, and updating the screen and such, this loop is going on watching the encoder. It uses a standard Arduino library to handle rotary encoders, and you make a call to it here and tell it which one of the encoders, because it can be set up where you can have multiple encoders in a program. You tell it which encoder, and it returns to you a pointer to the value. And then what they do here is they create a variable and assign the value out of that pointer so that we now know and count how many steps the encoder's seen. They then clear that counter to bring it back to 0. So maybe it says there's 3, and you clear it, it goes to 0. And then it says, okay, depending on whether it's going forward or backwards, we have to either add or subtract. What we have to do here is, if it's going reverse, what they're saying, make the count negative so that we're reducing the frequency, not increasing. Then we say, okay, is the count greater than 0? Did we see any pulses since the last time we did this? If we do, we need to make a change. We need to update the frequency. And what we're going to do is we're going to add to the current frequency how many times we've seen the encoder move, how many pulses times the frequency step. So if we've seen 2, we would move, let's say this was the 10 hertz frequency step. If we saw 2 steps, 2 times 2.5 would give me 5. So instead of going 10 hertz, I'm halfway to my 10 hertz. And this is where we get in trouble, because if we miss a step, we end up somewhere in between. And then we've got some checks here to make sure that we don't go too far or go below the minimum frequency, above the maximum frequency. Once you do this, these flags kick in and calls it to update the frequencies. And then we go back through this. We have a little bit of a pause here. We come back and we do it again. Let me show you what I did in my code. Let me pause a moment, load the other version of the code up, and I'll show you the change. First change is we have some additional steps in here. We now have 7. So of course I had to update the checks, but we have 7. The first one is actually 1 hertz, and we don't do quarters. We do the full step. If you're going to step 1, you go 1. If you're going to go 10, you go 10. If you're going to go a kilohertz, you move a kilohertz. Here's the original code over here if you want to see it. Here's 2.5, I'm 1. So we don't do that anymore. We don't do partial steps. We do the step you asked for, and that's all we do. Well, we had to come down here and add in our hertz. So we have steps 1 hertz now and steps 5 kilohertz in. And then we come down to the loop here that handles this, and we made some changes. We still do the same thing where and I went ahead and put in some code comments because that's what I do when I program. So anyway, we're getting the counter values, same as we did before, but instead we have a new global counter called total counter, and we increment it, and we use the ABS function to make sure I don't get a negative value. I don't care if we're going left, I don't care if we're going right, I don't care if we're going up, I don't care if we're going down. I just want to know how many pulses have we seen. So what we do is we keep the running count here. Each time we reach this, we say how many times you see. You see 2. Okay, it's at 2 now. It's at -2. It's at 2. Then we clear this counter so that we do away with this. It's back to 0 again, so that those 2 counts don't get counted again. Then we reach here and we say, okay, is my total count greater than or equal to 4? That would be D10 to D10 in a perfect world. And if not, I don't really do anything because I don't set flags. I don't update frequencies. I just go down and do a 10-second delay, but 10 millisecond, I mean. But on the other hand, if we've made 4 clicks, then we wait for 10 milliseconds. Now you might wonder why I did that. Well, because if you're not quite clicked into the detent, I want to give time for it to click over in the detent without incrementing things, without changing things. I want to stabilize the turn a little bit. So I give it a little bit of time, and I say we're not going to do anything. Hold up for for a delay of 10 milliseconds. 10 milliseconds is quick enough. You're not going to have any problem. It's not going to slow down tuning or anything. We then set the count to 0, the total count, our running count to 0. We then set our flags to update the frequencies, and then we decide whether it's negative or positive, and we make the correct increase. But notice we don't do any count times frequency step. We just increase it by the frequency step. This means that you can never go in between. You only can move the frequency you asked to move. We have the same checks for min and max. And then at the very last moment, we clear our counter, because you have to remember this is triggered on interrupts up here. So we can be in the middle of this code and still counting turns up here. And we don't want that. We want to process this and start out at 0. And so what we do is we clear that library's counter just as we finish this. We make our frequency changes. In the meanwhile, it can count new counts as you're turning, but we update the frequencies, and then we start all over again. We come back up and we start this process again. Remember, we zeroed this so it's 0 if you haven't turned the knob. We zeroed this so it's 0. That way, whatever we get from this is actual new pulses that happened since we updated last time. And so this process right here does away with the errors that we were seeing and getting in between and such. And it works very smoothly, as you saw. It works very nicely. So really that's it. And of course, once we added up here the ability to have a 1-step, we can come down here, and it's going to handle automatically, because if I increase the frequency by 1, I went up 1 hertz. If I decrease it by 1, I go down 1 hertz. So all of this didn't have to change just because I added some additional steps in there. So that's it. That's what I did. Hopefully you found this informative and maybe even entertaining, and hope that I'm moving in the right direction and doing things that you'd like to have in this little radio. If you liked the video, do me a favor, hit the like button. It's real easy to do, and it helps me greatly. If you're not subscribed, please subscribe. It's free. You can undo it later if you don't want to be subscribed. All it's going to do is it's going to make sure that you see my videos come up in your feed when new ones come out. But the most important thing to me is I hope to see you in the next video.